Okay, so now we're going to find the reference angle. Alright, so for part A, we have theta is 315 degrees. Now you don't have to draw the whole unit circle. You just need to know which quadrant 315 degrees is in. Okay, so as we know, this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then back to 360 degrees, right? That would be a whole circle. Okay, so 315, we know that's going to be in the fourth quadrant. Okay, so this angle, theta, is 315 degrees. And so we want to find the reference angle. Remember, the reference angle is the acute angle that's formed between the terminal side, created by theta, and the x-axis. Okay, so this is going to be theta prime. How do we find theta prime? Theta prime would be the whole circle, 360 degrees, minus the theta, and that would give us the acute angle that remains. Okay, so that would be 360 degrees minus 315 degrees, which is 45 degrees. All right, so that's the reference angle, and in the future we're going to use the reference angle to solve certain problems and answer certain questions. Okay? Now that's when it gets fun, it gets real. It gets real fun. Okay, so for part B, we have radians. We have theta is negative 13 pi over 12. Now, the fact that this is negative, I can see that we would probably want to find a coterminal angle so that we can have an angle between 0 and 2 pi, the unit circle, and we can go from there. Okay, so from here, I'm going to add 2 pi, but of course I want it to have a denominator of 12, so 1 times 12 is 12, so 2 times 12 is 24, right? So 24 pi over 12 is 2 pi. Okay, but now we have the same denominator. When I add, I'll get 11 pi over 12, which is indeed in the unit circle. Where is it? It would be in the second quadrant, okay? Because remember over here we have pi, so 12 pi over 12 is pi, and 11 pi over 2 would be before that. Okay, so this is the angle theta formed, and we want to get, let me use a different color, we want to get the reference angle, which is theta prime, is the acute angle formed between the terminal side, right, and the x-axis. Okay, so how do we get that? So theta prime would be the straight line 180 degrees minus the theta, okay? So what is 180 degrees minus theta? Well, it is not in degrees, so we would, instead of using 180, we want to use pi, since it's given to us in radians. Okay, so it would be pi minus theta. So pi minus theta, which our theta is negative 13 over 12. Ta-da-da. Okay, so here I see to use the coterminal angle. Okay, so we're going to do theta minus pi minus theta, where theta is 11 over 2. So of course, that's why it's always good to draw this. So this is going to be theta minus 11 pi over 2. Okay, so here we need to have the same denominator. Little mistakes, things happen. Okay, so 11 pi over 12. When I drew it over here, I put 11 pi over 2 by accident. Okay, but it's 11 pi over 12. Okay, so here I'm going to do 12 pi over 12, which is pi. Subtract 11 pi over 2, and that'll give us pi over 12. Okay, so this angle on prime is pi over 12. That makes complete sense because this is 12 pi over 12, or pi, minus the 11 pi over 2 would be the 1 pi over 2, or pi over 12. Okay, so very good. Let's move on to another one that's in the third quadrant. Okay, so here we have theta is 3.5 measured in radians. So we would have to find out which quadrant that is, right? So here, because we know that pi is 3.14, we know that this would have to be, okay, if we were to draw the unit circle, we know that we have 0 here, pi over 2 in radians. Here would be pi and 3 pi over 2, right? So 3.5, so since pi is 3.14, approximately, 3 pi over 2, you would have to do the math, but 3 pi over 2 is approximately 4.71. So that means that 3.5 is indeed in the third quadrant, okay? So we're gonna draw our angle theta. And now the question is, can you find the acute angle that is formed from the terminal side, right, which is this side right here, to the x-axis? Alrighty, so that's angle, maybe I should, instead of putting that there because it could be confusing, let's put the theta up here. Theta is the entire blue part. And then the reference angle, theta prime, is the acute angle formed between the terminal side, which is the ray at the end of the theta formed, and the x-axis. Okay, so how would we get that? So theta prime is theta, which is everything, minus 180 degrees, which is the line. Okay, now because this is given to us in terms of pi, we would want to use theta minus pi. Okay, well, theta is given to us as 3.5. 3.5 minus pi, which is 3.14, is approximately, you would have to round, 0.3584. Okay, so that would be this reference angle. Again, logically that makes sense. If all this is 3.5 and I just want to figure out what this little angle is, it would be 3.5 minus the 3.14, which is this portion, and that would leave me with just this part. Okay, so again, you could use logic to make this happen. Just know which each part of at least the x-axis and the y-axis gives you. Okay. Again, you could pause, go back, rewatch. And last but not least, let's look at the fourth quadrant. So the fourth quadrant is 25 pi over 4. Okay, again, I can find a coterminal angle. Okay, I can already see that here I can subtract. I'll just double check because I like to do things fast. 25 over 4. Why? Well, remember that you can have several revolutions, right? So if I take away 2 pi, it wouldn't be enough, right? So here, remember 24 over 4 is the same as 6. So if I take away 6 pi, which is 3 revolutions of 2 pi, then I can see that I'm going to get a coterminal angle, right? So what is 25 minus 24? That's just pi over 4. So this is an angle between 0 and 2 pi, right? So specifically, it would be right here, 45 degrees, but again, you don't need to know all that. This is pi over 4. And so it is this angle formed in the first quadrant. So this is the first quadrant. Okay, so then the question is, what would be the reference angle? Well, the reference angle is the acute angle formed between the terminal side and the horizontal axis. So that is actually the same exact angle. So there's nothing more we have to do except give pi over 4 the coterminal angle.